Sir, you are mute.
Okay. Now, am I audible?
Yes.
Okay. So we are in February-March 2022, paper 5-2. Here in question number 1, a student has a sample of copper 2 sulfate crystals, and if you see over here, there are water of crystallization over here, which suggests that it is a hydrated. These crystals are hydrated. The student wants to show that the value of x is 5. So that is our objective, that we have to figure out, or that we have to determine the number of moles of water that is bonded to one formula unit of copper sulfate in these crystals. Is this understandable to everyone?
Yes, sir.
Okay. The student uses the following method. Step 1, weigh a clean crucible on a balance. Reading to 2 decimal places, record the mass. Okay, so first we have recorded the MC clean crucible mass. Then in step 2, place the sample of hydrated copper sulfate crystals into the crucible, record them as. In step 3, heat the crucible gently for about 1 minute, then strongly for about 4 minutes, then record them as. Okay. In step 4, we have recorded them as, weigh the crucible and content and record the mass. Okay. So we have recorded 3 masses over here. Now, in part A, what the examiner is asking, identify the instructions that is missing between step 3 and step 4. Yes. Yes, can anybody figure it out? What instructions are missing between step 3 and step 4? Before
Let it
recording
cool
the
down.
mass, yes, very good. We have to cool it down. We have to cool the crucible. Good. Cool the crucible and content. In B part, explain why gentle heating takes place in step 3. So see, at first,
To dehydrate.
there is a gentle heating. No, we eventually we are dehydrating. When we strongly heating, it is
break the bonds
dehydrating over there.
Water.
Sorry, can you repeat, Rida?
Sir, to break the bonds between copper and H2O.
So that's what happened when we do the strong heating as well, that the you know that copper sulfates are thermally the sulfates are usually thermally very stable, so they don't decompose on a Bunsen burner. And see, the objective from the first statement is indicating us that it is not going to decompose, only the heating is performed to remove the remove the water from the crystals. So basically, it's at a room temperature, and you just start with a strong heating. What would happen that the crystals might come out of the crucible. They start the crystal maybe start spitting. So to avoid that spitting of the crystals, we initially heat gently. Okay. And remember, in case of a carbonates, because carbonates can be decomposed by Bunsen burner, so we do gentle heating to remove the water or to hydrate it, and then on strong heating, carbonates and nitrates usually decompose, but sulfates do not decompose on even strong heating. Okay. So here, to avoid spitting of crystals from crucible. Is this understandable to everyone?
Yes, sir.
Okay. Now next part.
सर वैसे क्रूसिबल होता क्या है?
Crucible is a, you know, a small a very small cup of a ceramic, and it have a one, lid over it, and we use it to normally we use when we have to, strong heating. We use this because when we do the strong heating, glass apparatus are not useful for that. They can easily be broken down on strong heating.
Okay, sir.
So can you
Okay.
explain why the crystals
So
are
it is a
fitted?
ceramic material. Because if you, due to a very rapid change in temperature, they absorb so much energy. So there is a possibility that the crystals start splitting. So that's why we do the gentle heating initially. So they gradually gains the energy. Okay. Now, name the apparatus that should be used to hold the crucible during the heating.
Tripod stand.
No.
Tripod.
If you remember, if some of you have performed the experiments in AS level, on tripod stand, there is a triangle pipe clay. And on that triangle pipe clay, we hold the crucible on it. So it's a pipe clay triangle. Now, the method is incomplete. State the steps. No, tripod. Okay. Basically, tripod stand is like this. Let me draw it over here. Under which we, keep the Bunsen burner. And on that tripod stand, we place one, a pipe clay triangle, which have a 3 outlets over here to hold them. And on that, we keep that crucible on it. Okay. So that is tripod stand. And here, this is a pipe clay triangle. And here it's a crucible. And here there is a burner by which we heat it. Is this clear?
Yes, sir.
State the steps that should be carried out to complete the method. Okay. So what step was incomplete? in this method? See over here that after 4 minutes of strong heating, we cooled it and then we recorded the mass, right? But here, whenever, yes, Ibrahim, good. Whenever we have to find out the value of the X or the water of crystallization, we have to heat the content until there is a constant reading of the mass on the weighing balance. So the step that is missing is heat the content to constant mass. Is this clear?
सर ये एक बार फिर बता दें क्यों किया है सर?
Because how could you sure after recording this mass that all of the water is evaporated or escaped? There must be a chance that must be some water over there. So we have to heat it again and check the mass again. If we got the two constant readings, then we can make sure and then we can consider it that all of the water is lost.
Okay, sir. Okay.
Now, E part. The student records their result in table 1.1. Okay. The mass of the crucible and the content before heating, and the mass of the crucible and the contents at the end of the experiment. Okay. Calculate the experimental value of X from these results. Okay. So, from these three values, I can find the mass of copper 2 sulfate and I can find the mass of water that is lost from that copper 2 sulfate. So, mass of copper 2 sulfate, or you can say hydrated copper 2 sulfate, then it would be actually equals to
21.09 minus 13.6.
21.09 minus 13.60. Yes, can anybody tell me the answer?
$7.49.
7.49. Okay. Now, I think that first value that I have recorded calculated over here is not needed. So when the water is lost, the mass that is left is 17.94, which must be a mass of CuSO4 only. So if I have to find the mass of copper sulfate when the water is lost, it must be equal to 17.94 minus 13.60, right? Can anybody tell me the answer, please?
4.34.
4.34. 4. Okay. Now, mass of water. So it would be actually equals to 21.09 minus 17.94. Yes, can anybody tell me the answer?
सर ये क्यों किया हमने तीसरा स्टेप?
1 minute, Abdurrahman.
3.1.
3.15
15.
grams. Okay, actually this is not needed over here. Okay, so if I relate that moles of or the mass of copper sulfate with the mass of water, so from here I have got this relation that with 4.34 grams of copper sulfate, 3.15 water is present, grams of water is present. Is this understandable?
Yes.
Okay. Now, if we go for the MR of copper sulfate, so MR of copper sulfate, because it's a 1 mole, so I have to find the mass of 1 mole, which must be equals to its MR. So copper is 63.5. Can anybody confirm me the value of copper? The AR of copper? Or I think there must be a product table at the end. Yeah, it is 63.5. Okay. So there is a sulfate which is 32.1. And oxygen is, there are 4 oxygens, so 4 times 16. So it would be equals to 63 and 32, 95.6 and 64. So 95.6 and 64 would give you
159.6.
159.6. Okay. So if there is a 159.6 grams of copper sulfate, then the mass of water would be X, that is unknown. Okay. So from that, you can find the mass of water, 159.6 into 3.15 divided by 4.34. So it would give me the mass of water that is bonded to 1 mole of copper sulfate. So can anybody solve and tell me the answer, please?
Sir, 115.8 आ रहा है.
Sorry.
सर ये आपने डिवाइड नहीं करना था 4.34 डिवाइडेड बाय 159.6.
Just tell me the value, please.
115.8.
115.8. So these are the grams of water, right? And in the formula, the X is basically represents the moles of water. So I will turn these grams of water into moles. So it would be 115.8 divided by the AR of water, which is 18.
6.43.
6.43. Is there any other figure after 3?
435 है.
435. So it must be then 6.44. So the experimental value of X is 6.44. Is this understandable to everyone?
Yes, sir.
So what we did, we find the mass of water that must be bonded with the 1 mole of copper sulfate, and then we turned it into a mole. So we will get the value of X over here. Now, in the next part, suggest why the experimental value of X varies from the expected value of 5. If you were unable to obtain an answer to E1, use the experimental value X is equal to 6.9. This is not the correct answer. So, okay, we have got the answer. Now, we have to comment on that uh, why the value is greater? Yes. Who can answer this one, this part, that why the value is greater?
सर कुछ पानी बच गया होगा.
Think again. If some of the water must not be escaped, then how could the value would be greater for the water? It must be lesser than 5, right? Because if you see here, they have said that the value of x is 5 if some of the water is not lost from the crystals, and the water that is lost is actually the lesser amount is lost, then the value of x would be smaller than 5, not greater than 5. But here we are getting the value that is greater than 5. So what will be the reason? Yes.
सर डिकम्पोज हो गया होगा कॉपर सल्फेट.
Yes, because it means that there is some more thing which comes out instead of water. So it clearly indicating that of the copper sulfate would be decomposed. Is this understandable?
Yes.
Okay. Okay. So here I will write that sum of copper sulfate must be decomposed now. Next part, the empty crucible weighs 13.60 gram. Calculate the percentage error in this measurement. Yes. How we would find the percentage error? The value of mass recorded by the balance is 13.60 gram, which clearly indicating that the least count of the balance would be 0.01 gram, right?
Yes.
And whenever, if the least count is this, then the uncertainty would be 0.005 grams plus minus, right? Okay. So that is the uncertainty. But normally when we record the mass on the wing, scale, we always take the differences. So it means we are recording the mass twice. So we would show the working that 2 times the uncertainty divided by the total mass and then multiply by 100 to get the percentage error.
सर ये 2 times का समझ में नहीं आया.
Because normally whenever we record the mass, we take the 2 values, the initial value and the final value, and then we show the difference, right?
सर इसमें तो कोई डिफरेंस ही नहीं होगा ना. इसमें तो हमने डायरेक्टली उसको इम्बैलेंस के ऊपर.
Okay, let me tell you, if you have used the weighing balance, so what would you do? First you press the tear button to make the reading 0, right?
Yes.
So when there is a 0, there must be a uncertainty of plus minus 0.005 over there.
Yes.
And then when we got this value, that 13.6, there is an uncertainty of plus minus 0.005 over here as well.
Yes.
So that's why we do the twice of the least count and then divided by the actual mass that is recorded and times 100.
Okay, sir.
Is this clear to everyone? So can anybody tell me the answer, please?
Sir, इसको
0.0735.
0.0735%. Okay. Now, question 1 is ended. Now, question number 2. Okay. The conductivity of an ionic solution can be determined by passing an electric current through the solution, measuring the conductivity using conductivity meter. The A part, student carries out an experiment to measure the conductivity of a different solutions of ethanoic acid, which is a weak acid. Okay. The acid dissociation constant Ka can be determined from this experiment. Okay. So that is our objective, that we are record the conductivity, and by collecting the data from the experiment, we have to determine the acid dissociation constant K for the ethanoic acid. The student makes a standard solution A, 250 centimeter cube volume of 2 mole per dm cube concentration of ethanoic acid. What is meant by standard solution? So standard solution is a solution of any substance, but if its concentration is known, then it is always considered as a standard solution. Okay. So a solution whose concentration is known is a standard solution. Now, part 2. Describe how the student should make a standard solution A from pure ethanoic acid. The concentration of standard solution A should be 2 mole per dm cube to the nearest 3 significant figures. Your answer should state the name and capacity of any apparatus that the student should use. A balance is not available. Okay. Pure ethanoic acid is a liquid, so they have told you that the state of the pure ethanoic acid and a density that it is of 1.05 gram per centimeter cube at room temperature. You may wish to write your answer using a series of numbered steps. Okay. So we are provided with the density, and they have informed us that pure ethanoic acid is a liquid, and from that liquid I have to form 2 mole per dm cube solution, aqueous solution of ethanoic acid. First tell me, is this understandable to everyone? If anybody have any doubt, do ask. Are the instructions clear? Yes.
Yes, sir. Clear.
Okay. So this is 1.05 grams per centimeter cube, right? If I divide it by its MR that is provided over here, then can anybody tell me the value when you divide 1.05 by 60? Yes.
0.0175.
0.01 0.75, and now it is mole per centimeter cube, right? Which means that 1 centimeter cube solution contains 0.0175 moles of ethanoic acid. And if I have to turn into mole per dm cube, so what I can do, I can, we all know that 1 dm cube is equal to 1000 centimeter cube. So if 1 centimeter cube have these number of moles, then 1000 centimeter cube must have X number of moles. So the value of X would be 1000 into 0.0175 divided by 1. So can anybody tell me the answer, please?
17.5.
17.5. And now can I write the unit that it's now mole per dm cube? Is this understandable to everyone? Yes.
Yes.
Yes, sir.
Okay. Now, they didn't inform you about the capacity of the, container in which you are preparing. So let's assume that we are going to prepare, if you recall the previous past paper, they have provided you 250 centimeter cube solution. So let's assume that we are going to make it in a 250 centimeter cube conical, volumetric flask. So it means that I have to know that to make a 250 centimeter cube of a solution having this much concentration, I have to know the volume of this, that how much volume of this would be needed. So if you recall the previous discussion, we can consider it as a stock solution or a concentrated solution, right? Yes, we can consider it as a stock solution or a concentrated solution. So I have told you one expression when you have to dilute the solution from the concentrated to the diluted. When we use this expression, that the concentration of a concentrated solution times volume of the concentrated solution is equals to concentration of a dilute solution times volume of the dilute solution. So volume of the concentrated solution is equals to concentration of the dilute solution. They have provided us that it is 2.00 mole per dm cube. We have decided that we are going to prepare that diluted solution in 250 centimeter cube of a volumetric flask. So I will take here 250 centimeter cube, and the concentration of the stock solution is 17.5 mole per dm cube. So can anybody tell me the answer, please? Yes.
28.57.
28.57.
Yes, sir.
Okay. So 28.57 centimeter cube is taken. Now we got the volume, that how much volume of a pure ethanoic acid is needed. So now I will write the instruction that pipette out 28.57 centimeter cube of pure ethanoic
सर
acid.
17.5 को cm cube में नहीं लेंगे?
17.5 is the mole per dm cube, right? It's the concentration.
अच्छा ठीक, sorry.
So 28.57 centimeter cube of ethanoic acid. We have pipetted out. Transfer it to. Now we have to mention the volume over here because they didn't provided you the volume, that in which volume you are preparing. So that's what we have decided on our own. So transfer it to 250 centimeter cube of volumetric flask. Then fill the flask up to the mark with distilled water. Is this part is understandable to everyone? If anybody have any doubt, do ask. Okay. The student wears chemically resistant gloves throughout this procedure. Suggest why. Yes. Yes, why the chemically resistant gloves were worn by the student? Aren't we using pure ethanoic acid, right? And if
It's
it's a
corrosive that.
pure, yeah, then it's a corrosive. So pure ethanoic acid is corrosive. Is this clear? Now, C part. The student dilutes standard solution A with the distilled water to make solutions of different concentrations. The conductivity of these solutions is measured. Table 2.1 shows the result. Okay. So here they have provided you the concentration, and on those concentrations, the conductivity as well. Now, in order to determine Ka, the results must be used to obtain two sets of data. Okay. Column 3 is the reciprocal of the square root of the concentration of column 1. And column 4 is the molar conductivity, which is found by dividing the conductivity column 2 by the concentration column 1. Okay. So we have to divide this by this. This must be in numerator and this must be in denominator to obtain the values for column 4. Complete column 3 and 4. Give all the values to 3 significant figures. Yes, who is going to tell me? Here what I have to do? 1 divided by under root of 0.0500. Yes. What is the answer over here? Yes. Who will be calculating?
4.472 pet.
4.472. So we have to, they have told you 3 significant figures. So 4.47. Next one.
6.32.
6.32. Next one.
8.94.
8.94. Next. Yes.
12.6.
12.6. Next. Yes.
17.9.
Thank you. 17.9. Next.
20.
25.30.
25.3. Three significant figures. Now, for the molar conductivity, as they have told you that dividing the column 2 by the concentration. So here the units are also helping you out that mole inverse. So it means that the concentration would be in the denominator. So it would be 3.76 exponent minus 3 over 0.0500. So kindly tell me the answer for the first one.
0.0752.
Okay, 0.0752. Next one. Yes. Just next value, please.
0.10, 0.110.
0.110. Okay, next one.
0.154.
0.154.
154.
Okay, next one.
0.213.
0.213.
0.213. Next value, please.
0.368.
0.368. Last value, please.
0.438. 438.
0.8. Okay.
सर हम लास्ट पर को राउंड ऑफ करते हैं या दोनों को आखिर के लास्ट पर?
It depends. For example, okay, just check, is it 0.438? Just verify, Halima.
ऐसे मेरे पास 428 आ रहा है.
752.
0.428.
752.
752. This one. Okay,
Last
Harsh,
वाले
the thing is that for example, if here the fourth digit is below 5, so we just take these 3 digits only. But if the fourth digit is 5 or greater than 5, then I would round off the next one and I would take it as 0.429 for 3 significant figures. Okay. Is this clear? Yes, sir.
Yes, sir.
Okay. Now, identify the dependent variable in this experiment. So what is the dependent variable? Yes, who is going to tell me the dependent variable and the
independent
Sorry?
concentration होगी.
concentration is
Independent.
independent? Yes, because we are choosing the concentration on our own. So that's why concentration is independent. And due to these concentrations, the values of the conductivities are getting changed. So the conductivity is the dependent variable. Is this clear to everyone? So here, conductivity. Now, the third part. The student decided to measure the conductivity of distilled water at the start of the experiment. Suggest why?
To act as control.
Sorry?
to act as a control.
Yeah, or you can say that actually to calibrate the conductivity of water. So we already know that how much is the conductivity due to water over there in the solution. Now next part, state one variable that should be controlled.
Temperature.
Good. It's a temperature because if the temperature changes, then obviously the movement of the ions changes as well, and as a result the conductivity would change. So for each of the experiment, the temperature must be kept constant in order to observe the effect or the change in conductivity due to the concentrations only. No, we are not providing any source. Saleha, is there any source? If you see, there is no source over here for the current. We are just putting the electrode to measure the conductivity from the conductivity meter. Now, plot a graph on the grid to show the relationship between the molar conductivity and 1 over root concentration of acid. Use a cross to plot each data point. Draw a line of best fit includes the origin. Okay. So we have to take these values. 4.47 is the 1 under root concentration and the molar conductivity is 0.0752. So 0.0752, it's 0.05. 1 minute. 4.47 and 0.0752. 4.45 over here. So this is 42444648. So zero point 0.0752. So it must be over here. Then the next one 0.11 and 6.32. Okay. So 6.32. One minute. Can anybody repeat the points for the first data? Is it 4.47?
Yes, sir.
3, 4. Okay.
0.0752.
0.0752 and 4.47. 0.0752. So it would be over here. Now, the next data point is on x-axis, it's yes, what is the value? 0.6 6.32 and 0.110. So 6 over here and 7 over here and 6.32 would be like this. And at 6.32, it would be 0.110. So
0.110.
0.110. So it would be over here. Now, next one is 8.94.
8.94.
So this is 8 and this is 9. So 8.94 would be closer to 9. And on y-axis,
0.154.
154. So it must be over here. Now
12.6.
12.6. So here 11, here 12, here 13. So 12.6 and
0.213.
0. It's 12.6, right? And 0.213.
Yes, sir.
So it would be over here. Now, next point is 17.9. So 16, 17, 18. So it must be closer to 18. 17.9 and 0.368. 17.9 and
0.368.
Okay. 17.9 and 0.368. So it would be over here. Now 25.3 and 0.428. 25.3. So 25.3 and on 25.3, what is the value? Yes, can anybody repeat the value, please?
0.428. 25. 0.428.
428. So it must be over here. Okay. Now what they have asked you to draw the line of best fit. So if I draw the line of best fit from the origin, so it would be like this. Is this clear to everyone? Now, circle one point on the graph that you consider to be most anomalous. The conductivity meter was correctly functioning. Okay, they have told you, it means the conductivity value is correct. Suggest one reason why this anomaly may have occurred during the experimental procedure. So I have to first circle it. So I have circled it over here. And they have said, as they have informed us, that this value is correct. There is no, error in the conductivity meter. So it, instead of being this concentration value, it must be going to lie over here. So in actually, its value would be somewhat where over here. So what I can conclude from this, that it is not diluted properly. The dilution is incorrect. Is this clear to everyone? The dilution is incorrect, and why we have concluded this? Because of this, that they have told us that conductivity meter is working properly. So if it's working properly, so it means the solution that we have made, we did some error in it, and we didn't get the exact concentration or the actual concentration that we have needed or that we have, written in the data. Is this clear to everyone? Yes. Now, the equation for the line of best fit is shown. Okay. Here, the conductivity, this value, okay, is 3.91 dm square Siemens mole inverse. Use your graph to determine the gradient of the line of best fit. Okay. So, state the coordinates of, okay, first we have to find the gradient. State the coordinates of both the points you used in your calculation. These must be selected from your line of best fit. Give the gradient to 3 significant figures. Okay. So, let me choose 2 points. And I can choose this one, that 0.05 and 5, right? No, 0.05 and on x-axis it's 3, this point. The second one which I can go for, maybe this one. On x-axis it's 10. And on y-axis it's actually 165.165. So we have chosen the gradients. At 3 and 0 point. One minute. 0.05 and the coordinates 2 are 10, 0.165. So 0.165 minus 0.05 over 10 minus 3. Can anyone tell me the answers, please?
0.0164. 0164.
0.0164. Okay. Now, what they are asking, determine the acid dissociation constant of ethanoic acid, include the units. Okay. So look over here. The acid dissociation constant, let me write this expression over here, is equals to molar conductivity, specific conductivity under root Ka over under root of concentration of ethanoic acid. Okay. So I have to find the acid dissociation constant. That is Ka. So what I can do, I can take the square both sides. So if I take the square both sides, it would become, sorry, square is equals to square into Ka over concentration of ethanoic acid. So if you relate it with the line equation, this would be y and this would be m, that is your gradient, and this would be x. So if you have to find the k, that k a is actually equals to, this would be the gradient, that is 0.0164 divided by square of this. So 0.0164 over 3.91 square. No, 1 minute. It's gradient, but here we have took the square root. So basically this whole thing is the square of the whole thing is taken. So can anybody tell me the answer, please? That way basically becomes m square. So it must be square as well.
1.77 exponent -5.
1.77 exponent -5. Okay, so the value of Ka is 1.77 exponent -5. Now you have to find out the unit. So
सर हमने दोनों का स्क्वायर क्यों किया?
because we have took the square of the whole this thing, right? So the gradient is basically this one having a under root of the concentration of ethanoic acid. So we have removed that. So that's why we have to take the square of that value. We have removed that under root. If you look at the y-axis, see.
Okay.
So if we have removed that under root, so that's why we have to take the square of this value as well. Okay, so the unit of Ka, see, okay, if I make the K subject over here, so it would be square of this divided by square of this and concentration, right? So these two are going to be cancelled out, so their units would be, so we are left with the concentration only, and the unit of concentration is mole per dm cube. Is this clear?
सर अगर हम स्क्वायर ना लेते
Yes.
में, तो हमें ओवरऑल स्क्वायर नहीं करना पड़ता.
Then you have to take the under root.
Yes.
You have to remove that the under root from the Ka. So finally you have to take the square. After you will get the answer. You have to take the square of that answer because you have to remove the under root of a Ka because Ka is in under root, right?
Okay, sir.
Okay. Now the G part. The student repeats the experiment with the propanoic acid. The numerical value of Ka of a propanoic acid is experimentally determined as 1.28 exponent minus 5. The theoretical value is 1.34 exponent minus 5. So the theoretical value is bigger and the numerical value is smaller. The practical value is smaller, the experimental value. Comment on the validity of experimental result. Assume the maximum total percentage error from the measurement made is 6.5%. So the percentage error is 6.5%. That can be the maximum, and you have to comment on the validity. So let's find the error first. So how would we do it? This take the change between these two values, that the numerical or theoretical value and the practical value, divided by the theoretical value because it is the actual one, and the experimental would be because of it is lower because of the error, and then times it 100. We will get the error, that whether the error is 6.5% or greater than this. So can anybody tell me the percentage error in the experimental value? Yes. Can anyone tell me, please? 4.4. Okay. So if you are getting 4.4%, so we can comment that the error, sorry, that the percentage error is less than the maximum percentage error, right? So the experimental value is valid. Okay. If this error that we have calculated over here, in the experimental value, if it is greater than the 6.1, then we can comment that the value that we have calculated or that we have obtained from the experimental results is not valid, because the maximum error that can be is 6.5, and the error that we are getting is greater than that, which clearly indicates that our results are actually cannot be validated. Is this clear? So tomorrow we will be going to start another paper 5. Okay. Take care, everyone. Allah Hafiz.